right, Jake, chapter 2 of your science. So far you haven't missed a single question all year in science, and I would love to see you keep that trend going. What an amazing accomplishment. All right, here we go. So you have your producer. Your producers capture sunlight to make their own food. You have plants, algae, and some bacteria serve as your producer. You know this one. Consumer. Consumers cannot make their own food. They obtain energy by eating other organisms. So your herbivores, carnivores, omnivores, they are consumers. You have your decomposer. Your decomposer breaks down waste and dead organism and return raw materials to the ecosystem. An example of this would be fungi or bacteria. Okay, so there's 4 types of consumers. Give an example and a description. So you have a herbivore, which eats only plants. That's a caterpillar and a deer. You have a carnivore, which eat only animals, like a spider or a lion. So think of a lion driving a car to get dinner, to go to Wendy's and get some meat. Okay, so carnivore, okay? Then you have your omnivore, which is to eat both plants and animals. That's a squirrel or a bear. I think humans are omnivore. And then scavenger. The scavenger feeds on bodies of dead organisms, like a vulture or a catfish. All right, so herbivores eat only plants. Carnivores eat only animals. Omnivores eat both plants and animals. And a scavenger feeds on the bodies of dead organisms. Ugh. All right, so create a food chain with 3 organisms. Label each organism with its energy role. So you start off with your sun, which goes to the producer, which is your tree. It drops on down to a mouse, which is your first level consumer. And then the snake, which eats the mouse, which is the second level consumer. At which energy level do all food chains start? They always start with the sun, and it goes from the sun to the producer. What is a food web? So a food web is many overlapping food chains in an ecosystem. So chain, when they combine together, create a food web. All right, draw an energy pyramid with the 4 sections and then enter the following organisms. So you have your grass, your caterpillar, your blue jay, and your fox. The grass is the producer. Your first level consumer is the caterpillar because it eats the grass. Second level consumer is the blue jay because the blue jay eats the caterpillar. And the third level consumer is the fox because the fox eats the blue jay. How much energy is actually passed from one section of the energy pyramid to the next? And that number is 10%. So how much is lost in an energy pyramid? 90%. The water cycle, what is the water cycle? It's a continuous process where water moves from the earth to the atmosphere. All right, so the water cycle has 3 parts to it: evaporation, condensation, and precipitation. Let me go back. So evaporation is when the liquid water absorbs energy and changes to a gas. So it goes from water to gas. Condensation is when cooled water vapor changes back to liquid, forming clouds. So it goes from the gas to the water. Precipitation is when collected liquid water in clouds falls down to the earth. And 4 examples of precipitation are rain, sleet, hail, and snow. All right, choose the letter from the diagram that best fits the water cycle step, then give the state of matter. So if we look at letter D, evaporation from the oceans. So the ocean evaporates up, that's D, and that goes from the liquid to the gas. B is precipitation. That's just the liquid falling to the earth. C is condensation. That's when the gas goes to a liquid. So if you look at C, which is right here, goes from the gas to the liquid. And then runoff right here, that's A. That's when the water runs off. All right, draw arrows showing the carbon-oxygen cycle. Who releases the oxygen? The tree. Here's a tree, and here's a cow. The picture looks bad, but here's your tree. So the tree releases oxygen to the cow, which breathes it in, and then releases carbon dioxide. Which process do producers use carbon from carbon dioxide to produce other carbon-containing molecules? That's called photosynthesis. So that's how plants get their food. Okay, they take in the carbon dioxide and it makes carbon-containing molecules. All right, here we have this nitrogen thing. This part's tough and the picture's difficult to see, so I'll do my best. Oh, let's go back to it. All right, so the nitrogen-fixing bacteria that fix nitrogen into nitrogen compounds, which are nitrates, do so in bumps on the roots of certain plants. So these bumps on the roots, which is right here, these are plant roots with little bumps. They're called nodules. Using the above diagram, place a square around the roots with the bumps. Okay, so here's the roots with the bumps. See, here's the roots, there's the bumps there. Okay, now, place a circle around the bacteria that breaks down waste and dead animals. So right there you see the circle, and that produces waste and dead animals. So something's rotting in the ground there. All right, and then place a star over the nitrogen compound that can be used by plants. So that's deep within the thing, and that comes from the nodules. All right, so the nitrates come from the nodules. Ugh, good luck with that. All right, climate. Climate is the typical weather pattern in an area over a long period of time. Climate includes average precipitation and temperature. All right, so climate is different from the weather because climate is over a long period of time. The biome, that's the group of land ecosystems with similar climates and organisms. So it's like groups of ecosystems that are similar. All right, so here's biomes, the 6 major biomes described in our book. You have a tropical rainforest, you have the desert, you have the grasslands, you have the deciduous forests, you have the boreal, which is the taiga, and then you have the tundra. This is hard, Jake. You got to really focus on these. So tropical rainforest is warm, humid, rainy. Has the largest variety of plants. Then you have the desert. The desert is less than 25 centimeters of rain. Okay, so it's dry. Rainforest is really wet, has a lot of plants. Desert is dry, doesn't get much rain at all. Then you have the grassland, which is the savanna. That's just grasses, few shrubs, few trees. Then you have your deciduous forests. Okay, that's oak, beech trees, the leaves drop. Okay, so your deciduous forests. Then you have your boreal, which is the taiga. This is a carnivorous trees. This is cones and needles. So this is like wintertime, like places where there's like snow, but not like ridiculously frozen. Okay, so this is like where you have your evergreens. And then you have your tundra, which is cold and dry, and it's like the snow equivalent of a desert. Okay, all right, so we've got to figure this out. Tropical rainforest leads to a dry desert, and then some grasses grow in the grassland, which leads to a deciduous forest, which then eventually turns into the evergreen forest that leads to the snow and the tundra. Okay, so rainforest, desert, grassland, RDG, DBT, RDG, DBT, RDG, DBT. Rainforest, desert, grassland, deciduous forest, boreal, tundra. Rainforest, desert, grassland, deciduous forest, boreal, tundra. Rainforest, desert, grassland, deciduous forest, boreal, tundra, tundra. I am so cold in the tundra. Rainforest, desert, grassland, deciduous forest, boreal, tundra, tundra, tundra. All right, enough. Okay, tropical rainforest, warm and humid, large variety of plants. Boom. Desert, less than 25 centimeters of rain, very, very dry. Boom. Grassland, savanna, mostly grasses, few shrubs, a little bit of trees. Boom. Deciduous forest, oak and beech trees. They drop leaves when the weather changes. Boom. Boreal, taiga, carnivorous trees, cones and needles, all evergreens. Boom. Tundra, tundra, cold and dry. All right, freshwater ecosystems. They make up a small part of the Earth's water. They provide a habitat. Freshwater ecosystem. So the water's fresh, small part of the Earth's water. They provide habitats. Examples are ponds, lakes, wetlands, streams, rivers. So there's no salt in these guys. It's fresh water. Then you have your estuary. This is where fresh water meets the salt water. So this is where rivers empty into oceans. Estuary. It's a weird word. Just think of the word with all the vowels. There's so many vowels. You got an E, you got a U, you got an A, you got a Y. Y can be a vowel some of the time. And it almost looks like a river going into an ocean. If you think of the Y as the top part of the ocean and the river's going into it. So an estuary is where the river empties into the ocean. All right, marine ecosystem. That's salt water. That's like oceans and seas, where the estuary is, where it's a mix, so marine ecosystem. Then you have your intertidal zones. That's between high and low tide on the ocean. Okay, so intertidal, that makes sense if there's a high tide, low tide, so it's the shoreline. All right, that's where the crabs are. You don't like that. You don't like the intertidal zone. Then you have the Neurotic Zone. That's where the edge of the land continent extends into the ocean. So your continental shelf. That's where your school of fish hang out. Your schools of fishes hang out coral. So this is if you were walking along the land under the water. This is where it stops. And then it's just all ocean. That's terrifying. The Neurotic Zone. Then you have the Deep Zone, located below the open ocean surface. It's dark. It's cold. It's home to many decomposers where just bacteria and algae just eat dead stuff. The deep zone. We all call it the dead zone. All right, that's it. Okay, great. All right, hardest part I think is going to be remembering the rainforest, tundra, rainforest, desert, deciduous forest. I can't remember, but you're going to remember. I love you, bud. Good luck. Knock it out of the park. Kick some butt.